Hey there, and welcome to This Explainer. When we look at massive modern infrastructure, the spotlight usually falls on concrete and steel. But behind the scenes, there is this hidden powerhouse making those massive structures completely possible. Today, we're going to dive right in and break down the incredible engineering behind an absolutely indispensable construction material. So let's set the stage here. What actually happens when building materials face extreme water and heavy loads? Well, in high-stakes heavy construction and logistics, the environment is literally unforgiving. We're talking extreme moisture, relentless weather, and massive load-bearing requirements that will instantly compromise standard materials. And when that happens, you get warped structures and delayed projects. You absolutely need materials engineered to take a beating and remain completely intact.
Okay, let's jump right into Section 1, Meet Film Faced Plywood. Now, you might hear the word plywood and think of standard timber, but no, this is an absolute engineered powerhouse. We're talking about a highly durable plywood panel that's been upgraded, supercharged really, with a water and impact-resistant film. It is designed specifically to thrive in outdoor, high moisture, and super heavy-duty applications. To put this into perspective, think about standard wood. It's incredibly vulnerable to moisture, right? It warps, it swells, and it has a lower impact resistance. But film-faced plywood? It takes that easy, familiar workability of traditional timber and basically gives it structural superpowers. By applying a highly water-resistant surface, you get a material with exceptional strength and long-lasting performance, creating a really practical solution for environments that would otherwise just destroy standard panels.
Moving right along, let's get into Section 2, the anatomy of strength. So what actually makes this material practically indestructible? Let's peel back the layers and look at the precise chemical and structural makeup. First up, the glue. It uses WBP adhesive. That stands for water and boil proof. That creates a bond so unbreakable, it literally won't delaminate even if you dunk it in boiling water. Then you've got the surface coating, a 120 to 220 gram per square meter phenolic film. That acts as an actual shield of armor against physical impact. And it's highly optimized for large-scale work, coming in standard massive dimensions like 1250 by 2500 millimeters or 1220 by 2440 millimeters, most commonly in really robust 18 or 21 millimeter thicknesses. But the protection goes way deeper than just the surface. To ensure massive load-bearing strength, the core of these panels utilizes incredibly robust wood types, stuff like birch, pine, or exotic hardwoods. Oh, and here's the real kicker, the edges. They are completely locked down. They're treated with specialized epoxy or acrylic-based waterproof paint, which completely seals off the exact weak points where water traditionally tries to sneak in.
All right, let's step out of the technical specs for a second. Section 3, Real-World Applications. Out in the field, this material is doing the heavy lifting. First off, you'll see it everywhere, building industrial formwork systems. Second, it's used for casting flooring and column molds. Think about it. When you're pouring literally thousands of pounds of wet concrete, you absolutely need a rigid, waterproof barrier so that concrete cures flawlessly. And third, stepping away from construction entirely, it's widely used for constructing heavy-duty truck and trailer beds. It effortlessly handles the constant, everyday physical abuse and weather exposure of transport logistics.
And that brings us to Section 4, sourcing your next project. Now, understanding the specs is great. But if you're actually looking to integrate this super material into your own supply chain, you should definitely check out b2bxm.com as an excellent reference point. When you're dealing with large-scale export and construction planning, you can't just guess. You need precise technical data, and that platform provides the exact standard sizes, thicknesses, and performance capabilities you'll need for bulk sourcing.
So, as we wrap up this explainer, we've seen how things like water and boil-proof glue, dense hardwood cores, and phenolic film shielding all combine to create a material that practically laughs at extreme weather and heavy impacts. Utilizing a shielded, boil-proof material like this completely changes the rules of structural design. It's a real game changer. So my final question for you is, with materials this resilient to your disposal, what will you build next?